Hi, good afternoon, everyone. Thank you for joining us. And this afternoon, we will talk about Docker, Python applications, and Kubernetes. We will talk about um, some of the architectures that we did in my company that basically saved millions of dollars for Dockerizing it and automating our internal toolings. And right now, I just want to ask. I think some of you are still installing Docker. So if you're using Windows or Mac, don't worry. You can always install Docker for Mac or Docker for Windows. And for Docker tools, I think there's the Kubernetes. It's already included in there, so you don't need to exert more time on that. And if you want to join us later on deploying our applications on GCP, on Google Cloud, so feel free to sign up, subscribe in Google Cloud. I mean, I'm not really campaigning or promoting Google Cloud, but as a developer, it's always good to have that knowledge on spinning up your servers on GCP or Google Cloud platform. All right. So our agenda this afternoon is we will together learn the basic of Docker, how to convert your Python application into microservices. So we either use Minikube or Docker Desktop or Docker for Mac or Docker for Windows. Learn how the basic of Kubernetes on your local machine and the intricacies between switching your Kubernetes from local to other instance of Google Cloud. Like for example, you have Google Cloud instances from Azure, and then you also have instances of GCP in there, and then you have local Kubernetes from your Docker for Mac or Docker for Windows. Yeah, that's actually one of the complexities that I encountered when I was learning Kubernetes. And yeah, if you wish to join on the Kubernetes on GCP, feel free to subscribe, because we will have you will learn and expect more wonders on Kubernetes on GCP, and then how to deploy your Python application in Autopilot, where we can tackle about deployment strategy. All right. So guys, I'm Paula. I'm an engagement manager at it's a PropServe at Pantheon. Pantheon is service provider. We usually host WordPress and Drupal, but of course, in the back end, we're using Python to automate our back end. Our platform is really built on that, on Go, and as engagement manager, we do system architecture for complex WordPress and Drupal structure, and we also do load testing. So later on, I'm gonna talk about load, because we were actually using AWS Elastic Beanstalk distributed load testing on AWS, and and I'm gonna talk about how we save thousands of dollars on shifting to GCP as containers. So we will talk about architectures around that. And yeah, so guys, for hello. So we just started, so don't worry. Do you have laptops with you? All right, so if you wish to join us in the workshop, hands-on thing, I hope you have a running Docker on your machines. So yeah, just connect. You have a Wi-Fi there. Go to docker.org.com, then install the Docker for Mac if you're using Mac, Docker for Windows for Windows. So this session is actually really for beginners. Like if you have no experience on running Docker, then it's good. And with Kubernetes also. And we will also talk about how we can transform Python Flask application into Dockerized with connecting with other services. Yep. So guys, I want you to be intimate because we're just like 10 of us here. You don't need to be shy out, and I don't want to to go out in this room later on without knowing each other. So maybe you can introduce yourselves, starting with our flower among the thorns. Miss? Kela.
Hi, Paula. And then all three of us are software engineers for freelancer.com.
Nice. Sir?
I'm Edward from Accenture.
Edward.
Lawrence, working as freelance. I'm Mark. I'm working as a freelancer. I'm Nico from DJ Davao.
Oh, Bisaya man pod.
Bisaya. Nice. Bisaya mo ito.
Bisaya mo na tulo. Oh, sige. Oh, ginisaya na lang ta mamaya. Sir?
Hi. I'm August, freelance DevOps from IBM.
Sir?
I'm Andre from DevOps from currently unemployed, but yeah.
Thank you, guys. And of course, Andre is actually a friend of mine in the community. And thanks for being here, bro. And of course, to our photographer, videographer, thanks for sticking with us, man. All right, so a long time ago, when container started to gain popularity, that was in the Industrial Revolution, where they were shifting goods via cargo and train. But during the time, they have a lot of problems. That's why they call this, I think before they called that M and N problem, or X and Y problem. Number one problem is the interaction. So, I mean, basic knowledge is you cannot bring together a gasoline and at the same time the fruits, right? Because there's gonna be a contamination happen that will gonna be happening when you do that. And they have this problem on how to fix that problem, on what kind of packaging or what kind of cargo, especially during the transporting of goods from cargo into train or vice versa. So, and as you can see, there's cargo, train from the factory, it goes to a train station, and then gonna be shifting around the goods. So there's a problem of how to take care of that product, and at this end we have the same problem with softwares, right? So they tried building this Ironcast, a container that can host different types of goods, may it be gasoline or a flammable product, or it can be a car or a winery, or expensive furnitures. So they basically solve the problem with that by using Ironcast rectangular package, which is super hard, that it can be transported without problems and can be carried by a crane. Because before they're using this nets, right? Long time ago, my cousin is actually a seaman. He works for a bulkery, so they still using crane, but they're using nets to transfer goods. I think they're transferring coal, and they have problems with that. Sometimes it gets busted, and the coal spills to the water. So it's always good to have this container. Same as with the software. So with the development of containerization, they built the Ironcast, and now they can organize. I don't know if you saw one of the video in History Channel, that this cargo is actually being managed by a system, and they can actually track this cargo in a very meaningful way. They have GPS on it. They have scaling sensor. They would know if that particular cargo is about to be degraded. They also have thermal sensors, especially if that particular product is very critical. And it's spawned in the software ecosystem. So before, we have static website, we have background workers, if you're using Celery, things like that. We have web front end, user database, queue, analytics database, API endpoint, hosted in one server. And sometimes, because of so much system, it's so huge that it even impacts the overall performance of that server. It could be in the physical server or in the software itself. And it's very hard to multiply it, to clone it, because of there's so much of integration in there. And that is the same with the cloud storage, where you will be hosting that particular software. With the physical one, there's cargo, train, there's factory. But with the softwares, we have on-prem servers, we have public cloud, and we have production cluster. So sometimes, because of this so much explosion in the modern times, it's very hard for us to choose what kind of technology we're gonna use. And sometimes it becomes complex managing the servers. I don't know if you heard about OpenStack. OpenStack exploded a few years ago, and all the giant cloud providers jump on it, and because OpenStack somewhat solves the problem on multiple hypervisors. Giant cloud providers uses different hypervisors. They have Windows, they have Unix, and all the X in there is very hard to manage. So now they're gearing towards that, and it somewhat solves the issue on. So with OpenStack, you can just collate all your resources and have that single endpoint to allocate resources. So and and that's where Docker container will be able to solve this problem. You can be able to host the static website in one container, and then the user database in a separate container, or you can use both of this, like static website and user database. Maybe your main is the static website, and you can sidecar user database as a container. So there's a sidecar container. You can do that, and then the rest they can be in a separate instance. And same with the storage devices or the cloud provider, because you can host this container. It's content agnostic, it's server agnostic, and that's how people love container, because it's everything agnostic. So and that solves the issues, because you can store everything on the container. And why containers matter? As I've said a while ago, for the in the industrial evolution, the physical containers can hold almost any type of cargo. And in the software side, it can encapsulate all your payload and its dependencies. So when we say payload, it can be Python, it can be C++, it can be any other scripts with its dependencies, or you can use a different packaging system in there, npm for Node, or pip for Python, and it's also hardware agnostic. So regardless of any shape or goods, you can use that container to host fruits or cars. And on the software side, you can use virtual machines, bare metal, on-prem, OpenStack, public infrastructure as a service without modification. So that's the great term now. Without modification, you can basically shift to any other hardware provider. And content isolation and interaction. So it says here, no worry about anvils crushing bananas. Containers can be stacked and shipped together. So, and it's the same with on the software side, because the resource and the network, and it has a complete isolation of the contents, and it avoids dependency. And in terms of automation, for the goods, you can basically you can easily transport your products, automate loading, unloading, moving around from train station, going to the ship without problem. And same as with the software, because you can always start your services without problem, because you don't need to reboot the system. So that's really one of the great feature of Docker. And you can even perfect for DevOps people, because you can use Docker on your CI, may it be Circle CI or Travis or Jenkins, and it does auto-scaling. It can, when we say hybrid clouds, you can even set up a way that this particular system runs on AWS, and if I wish to transfer this on Microsoft Azure, I can do it in just a matter of minutes. Especially on Kubernetes, they have this fleet of providers. You can either have Microsoft Azure, AWS, and GCP, and you can perfectly switch to them without problem. And highly efficient, of course. In terms of security, you cannot just open that particular container because it's too hard. I mean, nobody can just destroy it without, you cannot just destroy it unless you're using, what's this? Iron cutting device. And for the Docker, it's lightweight. It's virtually no performance or startup penalty, and it's quick to move and manipulate. And separation of duties. So shipper worries about inside the box, carrier worries about outside the box. So it's same with the software. Developer worries about the code, and ops worries about infrastructure. So there's no problem with that, and there's a very efficient separation of duties. That's why we are using containers. Any question to that, guys? All right. So it's number one, it's secure. Containers isolated. Containers isolate application from each other and the underlying infrastructure. And of course, you can't say that by using containers you're 100% secure. No, sometimes it's also depends on how you set up your security tokens. Sometimes some people are using passwords or credentials directly in that particular file. So it must be, it shouldn't be displaying those credentials. And one of the best features if you combine Docker and Kubernetes, because Kubernetes can give also a secure way of providing credentials, and we will do that later on during our workshop. And it's containers based on open standards. So major Linux distribution supports it, and Microsoft OS with support for every infrastructure, and lightweight. It still depends on how you set up your packaging. If you're using Python, some people are using Ubuntu image. Ubuntu image, sometimes it's huge. And if you're running Python, I would recommend to use the lightweight version. I think the lightweight version of Python is like 150 or 250 megabytes. And because if you're using Ubuntu, it's completely, it has a lot of features in it that you don't really need. Like, for example, the slimmer version of Python of the Docker image is it has no Vim, or it has no Nano, I think. So if you want that, you still have to install it, because you don't really need those editing tool inside the container, because you don't really need to edit something in there, because that's what Docker is. It's not what it's not it is not how Docker was designed to go to your Docker container, edit something in there, because it's supposed to be running in automated fashion. And they start instantly, yes. So you can save lots of RAM and resources. Images are constructed in layered files. So when you commit something, it doesn't need to compile everything from ground up. It will just append that particular commit and add that layer in your container. And plus, if you're using CI, it's even more faster, because it can store cache in every execution. And they can share common files, making disk usage and image downloads more efficient. When I was talking about Elastic Beanstalk, that was like 4 years ago. I think it was like 2 months after they released the Elastic Beanstalk, and then I jumped in the bandwagon and submitted a topic at DrupalCon, at Drupal Camp Singapore, and I talked about Elastic Beanstalk and how to provision thousands of servers in a matter of minutes. So I talked about it, and then when I was in the conference, I was presenting this particular topic, the container versus virtual machine. And I talked about this, and then somebody stood up and he begged to disagree with virtual machine is much more efficient than container. He works at, he studies, I don't know if he studies or he teaches at Harvard University. And then he talked about virtual machine is much better than container. And he was the only one person in that room that is really a pro virtual machine. And now we still love virtual machine, but with this premise that container is much more efficient than virtual machine. And then I think it was really hard that he explains that, I think it's a Microsoft guy. He talked about the new products of hypervisor. And I think most of the people there stood up and sided with me. Of course, yes, container is much more better than virtual machine. And in terms of, if you can see this, with VM, you have a guest OS, and this guest OS, that takes a lot of space in your machine. Errors, or if there's none, and then it logs into a file. And then if it's a WordPress, if that particular site is a WordPress, then there's a set of commands that it processes, like using, if you're familiar with WordPress, so there's a CLI commands for WordPress that gets all the plugins and checking it if there's alpha version that they're using on production. And if they do, we flag them that, hey dude, you're using alpha version of plugins on production. That could be, that's vulnerable, security vulnerability issue. And if it's using Drupal, there's a set of instruction. We're using drush. It's a CLI commands to check all the modules. If that particular module is on alpha or beta or dev version. So with that, we also flag them that, hey, it's on production, but still you're using an alpha version. So then it stores that in a file, and then files. And then we get the database if there are MySQL slow queries, and CDN if it checks that particular site if it's a global CDN or not, and then it also checks the Redis instance if it has a 100% hit efficiencies, and then it merged that data and then push that on gist for the purposes that you can go back to that data and check. So these are automated, and we're using Node.js in here. Node.js. Okay. So I don't know if you're familiar with New Relic. So New Relic is a performance monitoring tools. So what we do is we are using a Puppeteer. So Puppeteer is a Node.js automation tools that automates. It's like a headless Chrome library. So I'm using Puppeteer to log in to our system and goes to New Relic and do some screenshots. And these are not just ordinary screenshots. It can actually screenshot based on class or based on div ID. And then that image will be uploaded to Google Drive. So this is Node.js, and then uploading of the images will be handled by our Python container. And then once the images have been uploaded, it uses a Google Slide API to basically, so this template is a 60-page report, and with this text files that we fetch from the servers and from these commands, we basically replace the placeholders from that template and replaces all the values and the images. And what I like with the Google Slide API is that you can really target, like the logo of the company. So of course, you will just screenshot probably a 200 by 200 pixels, and then one of the template there has a placeholder to basically replace that placeholder as an image. And imagine if there are like 50 placeholders in that template, and when this is being handled by a Python script that basically replaces all those placeholders with images that we've captured earlier, and then it produces a final report. And from a 6-hour job, by automating this, I was able to reduce the amount of time to 2 hours. And this is just from 6 hours, naging 2 hours na lang. And that's, that's really a lot of time. Because before, I can't really go out, just that. But when I was able to reduce the building of our reports, I can use those 4 hours to study and to do some stuff. And hindi pa siya nada-Dockerize during that time. And and then my boss told me, why not? Because this automation script if you're gonna install this on another system, another laptop, it will take 3 hours. And that's not acceptable, right? So what I did is I Dockerize this. So by Dockerizing it, I separated all the shell script in one container, especially with the green one. So these are my shell scripts. And then I also have a MySQL container that process all the MySQL slow queries. And then I also have Redis container that does the analysis of Redis, if it's doing a lot of hit rates or not. And then I also have Python container that basically process the reports. And with this, I was able to reduce the time of installation. From 3 hours, I was able to reduce it to 30 minutes to 45 minutes to install this. But without, I mean, they just need to run the script, just one command, and that's it. With that 3 hours, you have lots of, I mean, before it takes a lot of, there are a lot of steps that you need to set up. And so Dockerizing our application really helps us. We were able to reduce from 6 hours to 1 hour. And and that's a good thing. Guys, so do you have a Docker running now on your machine? Fusion X1 / Pycon APAC workshop. And for the newcomers, guys, make sure that you have a running Docker. And if you wish to join us later on deploying our application on Kubernetes, on GCP, feel free to subscribe in Google Cloud Platform. They have 33 months free. I'm not really. 12 days, 12 months na pa. 12 pa rin? Oh yeah, oo, 12 pa rin pala.
Pero kailangan may card.
Yun lang. Yeah. Kailangan may card.
Anong number? Kailangan ng card.
All right, so can you check, guys, if you have what version of Docker you're using? (1809). Yeah, I think that's the latest one. 1809. Nilower ba ni Doc? Yung 22 na, okay. Lamig pa din. Okay, everyone who uses Docker starts with this command. Docker run hello world. So when you run this, it basically pulls an image for hello world. And if that particular image is not yet on the system, then it tries to download that. It's very, very slim, so it will not take time. But what it does is when you run this, it finds for that image. If that particular image is not yet on your system, it will try to download it, and then it will just, when downloading is done, it prints hello world. Very basic. It's like echo print. If you're on C, print hello world. And these are the basic Docker CLI commands. And this is the command for the Docker build for running a port. We will go through this, not all, but most of the important commands here. We will go through and we'll explain these commands. Okay. So if I am to select my top 5 that I usually use when doing Docker, so first is Docker build, Docker run, and then I usually Docker push, and then Docker image remove. Yeah. But let's check out our workshop here. So we have workshop 1, workshop 2, but don't jump in there yet. So we have here a Dockerfile. And, oh, sorry, not. So there's an app, right? So this is the app that we're gonna Dockerize, all right? Because right now this is a standalone Python based on Flask. And this means that you have to manually pip install socket, or we have to pip install Redis and Flask. And if you have no Flask at all, then you also have to pip install that, and that takes time, right? And manually doing that is really tragic. Not even requirements.txt, right? So this is the very, very basic, okay? So let's go to that file. So cd up. No module name Redis. All right. So if you're a really beginner, you're not really even thinking doing the environment, virtual environment. So this is actually me doing this kind of stuff from 3 years ago. That I don't know about virtual environment. Because my background is actually a PHP. I'm a PHP guy. And what I do, if I see .py, I just do Python that file. And that's not how Python script works. You have to, encapsulate this in a virtual machine, in a virtual environment, so that you'll have a fresh installation of your packages and things like that, right? But since I'm a noob, so I have to pip install Redis. Ready satisfied. Not even well. And I said, I don't know how to run this. So I switched to Drupal because I can't run this. That's actually my experience when I was learning Python. And I was really the same experience when I was learning Drupal, but back in the days. That when I installed it, I just see a lot of boring text fields, text. So I turned away from Drupal and I went with Joomla. So back in 10 years ago, I was actually part of the Joomla Philippines. I was one of the founders, and I easily bore if I see text versions of those boring stuff. But again, now let's go to our workshop number 1. So guys, who among here using IDEs? Me, I'm using Visual Code, and I'm not really promoting Microsoft products, but this is actually one of the best open source project that Microsoft gave away to the community. And I just love it. I mean, I'm using a lot of editors. JetBrains. I mean, JetBrains is really great, right? So yeah. All right. So let's check this out. Small. So this is a Dockerfile, and we're using Python 2.7-Slim. I think 2.7 will be phased out in, I think, next year. Yeah, but there are a lot of systems still using 2.7. And so we're going to use the Slim version. Slim version is like 150 to 200 megabytes. And there's already a loaded of Python stuff in there. Sometimes, this is what I've been trying to talk with my colleagues, that because most of them are using Ubuntu, because that's the image that they usually download every time. So they just use the Ubuntu, and Ubuntu usually go bigger. I mean, by just running around an application like this, sometimes it takes like 900 to 1 gig of image, and that's huge. So I usually prefer the Slim version. It's just like 250 megabytes, and then the work directory. This is where you set up your application directory, your document root if you're in Apache or Nginx. And then I have the application on my host machine along with the file. So basically just copying that over to the app folder in the container. And then it runs all the needed packages using the pip install and the requirements. I think I only have 2 packages inside that, Redis and Flask. And then I feel free to change this. Right now we expose the port 80 and this environment. This is how you inject environment variables to your container. Sometimes we are using environment to inject credentials, but yeah. For me, it's not secured yet in that way. I don't usually inject environment directly from Docker. I usually inject credentials from Kubernetes because it can safely inject security credentials on that. And we will talk about that later on. And then just running the Python. And first thing to do is we build first our image, okay? Let's do that. Oh. Okay lang guys sa likod, nakikita naman. Lagyan ko pa. Docker build -t. Okay. If you're gonna host this on your local machine, then you can name it whatever you want. But if you wanna push this later on Docker Hub, then you should, if you have accounts on Docker Hub, you can your account name / the project name. Let's say Pycon Workshop 1. And then the tag. So that's what you're gonna execute if you wanna push this on Docker Hub later on. But since I'm not gonna do that, I'm gonna push this on the Google Container Registry. If you're using GCP, they have this container registry. Its name is Google Container Registry. Now it's using gcr.io / the project name, Pantheon CS apps. Okay. But for others, or just if you have no account yet on Google Container Registry, just name it whatever you want. Anyway, when we execute this will just create the image on your local machine. And then the name of my application, which is Pycon Workshop 1. And then tag 1. I can do my tag as version 1 or latest. So regardless if it's a digit or alphanumeric. So I'm gonna do this. So and then that means that you're gonna run the Dockerfile in that current directory where my Dockerfile is in there. So now I'm building the Docker. I'm using the Slim. Since I ran this a while ago, then it should be done faster. Okay, we're done. Now we can check if we have. So to check if that particular image is already in your system, you can just type in Docker images. Yeah, I have lots of rep Pycon. All right, so we have here. So this is the image that we've just pushed 25 seconds ago, and it's just 131 megabytes. imagine that if you're on AWS and you're using Ubuntu as your base image, that's around 600 to 700 megabytes. And the leaner your application stack or your base image, the more efficient and faster its response, its app server response time. Okay. Because the mentality here is you just need to add whatever necessary. Because you don't need to include Vim or editing tool or things like that. As long as you can run your Python application, that's it. That's a good. Now that we have now that we have the image built, we can now run it. So Docker run -it, and then you can either use the container ID or the container name. So I will be using the container ID. Oh, sorry. So since this is actually running on a different port, we can actually -p, which is port 5000 over 80. So this means that it's port forwarding from 80 to 5000, so I can be able to navigate to localhost /5000. Okay, it's already allocated. Sorry. Port 80. Okay, let's use port 80. All right. So we're connected to our built application. If we can see the app.py, it's actually connecting to a Redis instance. So this is not just an ordinary Flask application because it connects to a Redis instance with the password. And then it also set a record in your Redis, and then it fetches a record. And we're pretty much working, our container is working now on our local machine, and that's good. Guys, sir?
It's a Dockerfile.
Yes.
Starts with a 2.7 Slim.
Yes.
So it will install that.
Yes, it will basically download the Slim 2.7, which is 150 megabytes. And then when it runs, it installs those packages that was included in the requirements.txt. So it's automated already. It will install that for you when you Docker build.
Requirements.txt, ito yung gagawa.
Yes. Or I think I already included that in the repository. So if you have packages that you want to include, you just need to include there.
Ito yung mismo gagawa.
Yes. But since this, I think I've already yeah. So as you can see, I just added the package without version. So if you wanna include the version, then you just tag it, and then you put the specific version. I think flask equals then the version. But since I want the latest version of Flask and Redis, then this is, I don't care of the tag.
Can I have the repo?
Oh, wait.
I have another question. What does it mean when your Dockerfile doesn't start with the OS that you want to use?
Sir, ulit.
What does it mean when your Dockerfile doesn't start with the OS, like Ubuntu Alpine, for example?
What does it mean if?
When your Dockerfile doesn't start with the OS that you want to
Okay. From my own understanding, if your Docker file has no operating system, then it won't run at all because it needs that OS to run that application. It's like running your application without operating system, so it will have an error. Yes. Oh, sorry. What? Let's see the.
Base image, something to start from, unless you're using something like Go that can just give you a binary. But like, it always, all Docker files start with the from.
Yeah, from. So
Does that have an OS? Specified in there?
What's the base image? What's that Python 2.7 slim based on? What's the base
It's
image?
already inside there.
so let's check. So you can actually easily check that. So we just need to go to Docker Hub and check the Python official Python repo. I think this is based on Python. 2.7 Slim. I think this is based on Alpine. 2.7 Slim. Here you go. Jesse 2.7. Slim Jesse. Oh, there. 2.7 Slim. Debian. It's based on Debian, so stretch Slim.
I was assuming it was going to use the OS of the host, but aren't.
Yeah, actually, I thought it was from Alpine because Alpine is more slimmer. So yeah, if you want to really dig into the base image, you can just tap into Docker Hub and check how they end up with that Python tag. And as you can see here, they are actually commenting the bugs that they found and the certificates. These are the GPG key to pull that updates, and the packages that's needed, so you don't need to over install it. So they already have GCC. I think that's one of the biggest packages that is being installed in Python, GCC. That we only use in our company, and it's in a private repo. All right, so let's go back to our application. So guys, who among you here was able to run the command? Okay, sir. All right. And we're using Jinja templating system. I like Jinja because it's so lean. And if you're used to Smarty template, I don't know if you're from PH. Sorry guys, if we're from PHP background, so usually talk about that. So, and I think based on that, you can say our age. I mean, you can determine our all right, so enough with that. So now we have our Docker image. We were able to run our application based on that image that we. And what if I wanna create a routing? So just to update the instance. Then paano natin gagawin yan? How do we manage updates on our base image? So let's say we add an app route. Okay, good. Okay, so we've just updated. We added the routing. It's named /pop. A page that does pop. So how do we start from that? So we exit first. So we again run Docker build. Sorry. And I'm gonna get this image, the container ID. And try to refresh this. It's the same. And then if I go to /pop, 404 not found. Okay, error. Anyway, I just I failed, so I needed to run my Docker build again. I can go to index tag 3. I'm done, and then try to run this again. The host name change.
Try adding 5,000 ports.
Up. Nakakano port. No. Port 80 yun eh. But that's, I mean, that's a default.
Is it running the new container or the old image?
Port 80 yan eh. That should work. Sorry. So this is the basic of rebuilding your images. But in production, you should be using CI to automate these things. Docker push.
Did you save? Because it used the cache when it built. Oh, okay, it did.
Sorry.
Oh, yeah, build mo na.
Docker run.
So you're connecting to it. Wala lang ano. 404 lang response. So it's the right container.
Anyway. Show Python app.
You're running the image. You're supposed to run. No.
Tama naman eh. Yeah.
Try mo run mo na lang yung image
Okay, dun lang. This. Gusto lang naman natin i-prove is yung changes eh. Hello, Pop. Let's see if that, baka mali lang yung na-update natin. Let's see. All right, so now running Docker run. No, and yeah, it's not. Yeah.
Run, Docker run, tapos yung tagline mo lang. Try.
Mali nga. GCR Pantheon PS apps Pycon WS1 Yes. Di pa rin? Kumana sa'yo? I don't know. Cache?
Sir, baka kailangan lang i-reload yung Flask na app. Dapat bagong app yun, bagong refresh. Chrome cache.
Huh?
Are you running? Baka it's running already in another port, another. You have the old one running still in port 80.
Ah.
Parang we run it, parang bagong start. Wala nang reload.
Ito tatlo. Tumatakbo. All right, so I'm gonna close this up. It did run with kill 99. All right.
Ibang hostname, iba hostname.
Nag-change yung host eh. Di ba?
For yung app.py. Okay, you're editing the wrong app.py, you're editing the other directory. Ano ba yung directory mo? Yung app.py.
Oo nga, no?
May app folder pa rin sa
Oo, tama. Projects, Python APAC.
Nakaroon directory mo. APAC workshop. Oh.
Bummer. So, sorry, maling folder yung ina-upload natin. Anyway, so I'm gonna change this up. I'm gonna Docker build this at 6. Alam mo kung minsan, you've been doing this kind of stuff, and then in the end, it's just like, oh, you're editing a wrong file or in a wrong directory. So anyway, so after this, we'll jump into workshop number 2 and scale this up and play around with Kubernetes. Docker. So we'll Docker run this, and I think this time this should be hello pub. Yep. All right, so let's talk about workshop number 2. And on our workshop number 2, we have 2 containers. One is the Redis container. So we're actually gonna build our Redis. This is now production grade Redis. So what I did here is I provision a persistent volume disk. When we say persistent, even if if the pods is deleted, your data is still safe, and it will still be there. It's just like elastic block storage in AWS. So in GCP Kubernetes, it's PVC, persistent volume claim. Actually, the reason why I added the separated YAML files for each of these, because I wanted you to be able to see that there's actually an order. So first is the secret YAML. As you can see, Kubernetes can create a secured way of injecting credentials. As you can see, I'm actually passing Redis password to our Redis, and this is the YAML template for secret API version v1 metadata. The name is Redis-secret, and this is the name that we will be using to incorporate to our container. As you can see, the Redis password here, this is just a base 64 of this is just the base 64 of the real password. And of course, it is not secured to put on your credentials, even if it's just a base 64 value. Usually, the secret YAML files, we do not include that to our repository. And sometimes the secret YAML file, we usually recreate that when we run our SQL CI or any CI, and then recreate this secret YAML. But we don't usually put that on the repository because it is dynamically recreated when it tries to build inside the Circle CI. Next is, so first is we execute the secret YAML file to inject the secret file. Next is we provision a persistent volume claim by doing this. So this YAML file is to provision a persistent volume, and this is the name, Pycon pbc-redis, and then the access modes is read-write ones, and the storage is 5 gig. So that's pretty much the default data in GCP. Then next is the creation of the stateful set. As you can see in the stateful set, this is where we add a Redis image. So I'm using the official Redis image, Redis 3.2 Alpine. That means I'm using a leaner version of Redis. And then I added here a Redis pass. This is actually being passed by the secret YAML file. And then with those attributes, and the port is 6379, which is the default port of Redis. And then this is the portion where we fetch the secret and then pass it over to Redis pass. Secret key reference name Redis secret. So this is actually incorporating the secret YAML file that we executed a while ago. And then the volume mounts, you can specify which directory that you're gonna be putting this volume or disk space. So the slash data, this is where the Redis data will host. So meaning if we have Redis in there and all of a sudden our pods just destroyed, then we can still reuse the data because it's persistent. And then the persistent volume claim. This is the name of the name of our volume. As you can see, these are 4. So we don't need. I mean, you can actually combine this all together in just one file.
What does it mean by having a claim on a persistent volume?
Okay, so in GCP, the way you provision a volume, a disk space, or a persistent volume, you have to request and then claim. So you have to execute the PBC by making that YAML file with all those provisions. So it's just like simply requesting Google Cloud, hey, I want a persistent volume, and that's it. So yeah, just a request for a persistent volume, and then incorporating that volume to your replication controller. Sorry, stateful set.
Persistent volume is not persistent volume claim, right?
Persistent volume.
Versus
Persistent volume claim.
Actually, persistent volume is that's actually what you need. Okay. The persistent volume claim is just a term that coined by GCP to request to be able to receive that request. So persistent volume claim. So it's just like it's not two different stuff. So now what I can do is we run this Redis container. So Redis, so all the YAML files, I actually added it on the Kubernetes folder. Okay. Workshop 2, okay. Now I'll be careful on what folder I need to edit. So Redis. So now K8, okay. So here are the files. So I'm using kubectl. Kubectl is actually part of the, when you install Google G Cloud, it's a CLI of Google Cloud Platform. So it's part of that software that you install. So kubectl apply. Chef. So first is the secret, and let me first create a namespace. Okay, so in Kubernetes we have a namespace. This is how we organize if we have multiple projects within our Kubernetes. So we can organize it by creating namespace. So let me create first kubectl create namespace. Namespace Pycon APAC 2019. So we can organize all our resources in that namespace. Then now I'm going to apply our secret YAML. So kubectl apply namespace. APAC 2019. I mean, in reality, we just add this YAML files into a single file, so we can execute it just once. And now I'm gonna run the queue, the PBC. So to request for a persistent volume claim. Okay, it's now created. Now, next is we incorporate this to our stateful set. Okay, Redis is now running, but we cannot, I mean, at this point, Redis is now running on that machine, but we cannot access it publicly. So we have to we have to run our service. I think I forgot to just. Let's see the service. So service is just simple. It basically provide a public accessibility to your load balancer. So it gives out a public IP where you can access that Redis. So I'm going to run this service.yaml. Okay. Now, how do we know if our PBC has been created, our stateful set has been there, and our service has been implemented, or if that particular IP is already provisioned? So first, let me check the get service or SVC, then namespace, because I have a lot of project. If I'm not gonna put a namespace, it's hard to read it. Namespace, Pycon APAC 2019. All right, so now we have our external IP. And our port is 6379. So how would we know if that particular IP is a Redis? So fortunately, I have a client Redis installed in my machine. So Redis-H and then the IP. .34.80.18.102. Now I'm connected. And do we know how to manipulate Redis? How to check if there are files? So usually you just put keys asterisk and it will show you the data. So basically, because it's fresh, there's no file. But it says here, oops, authentication required, because we specified in our Redis YAML file that there should be a password. Okay. Now the password is auth my Redis awesome. I think that's the password. Okay, we're in. And to check if there are, okay, it's empty list. But we have a working Redis. It has password. And now we can now configure our app container. So our app is actually just basically the same as with a while ago. But now that we have a new Redis instance, we just need to change the IP so we can use this Redis. So palitan lang natin to. And then the password is still the same. Just the ad hoc way. The workshop number 1 and workshop number 2, the only difference is the Redis that we're using here is an external Redis. But on workshop number 2, the Redis is actually from our it's homegrown from our container. I mean, that we just created. And this is now on port 5000. Okay, so now we still need to Docker build it because we updated our Python files. So app container. Now I'm gonna Docker build it again because but this time I'm gonna tag this as 7. So workshop 1. Okay. So now we're actually building this image. A while ago on workshop number 1, we just Docker build it in our local machine, right? Now we are gonna push our Docker container to Google Container Registry. Okay, and we're gonna use this repository URL. So we're gonna execute the command docker push, and then this repository name along with the tag name. But before I execute this, let's check our Google container, our Google Container Registry. So if you subscribe to Google Cloud Platform, you will see this dashboard that we use in GCP. So now we're gonna check first our Google Container Registry. There, images. So I have a bunch of images here. And as you can see, there's no Pycon-workshop 1, right? Workshop 2. So our workshop 2 is actually, we named it with workshop 1. That's confusing. Not yet. So I'm gonna just to make it right, we Docker build because I don't want to push this. So workshop 2, Docker build. We just change the name so that it's proper and correct. Docker build -t. Oops. Okay. Huh. Parang hindi siya directory. Okay. Okay. Docker build. Hindi ko nakikita yung kan. Yep, walang that. There. Alright, now Docker push this. Okay. So this takes around 2 to 3 minutes, sometimes faster, depending on your internet connection. But as you can see, I pushed some of the layers before that. Oh, it's now done. Let's check. Let's refresh this Google Container Registry. Oh, there. So we have our Google Container Registry. Tag 1. It's there now. And we will use that on our pods, on our replication controller. Okay, save this. And now we're ready to apply our YAML files for app container. So kubectl apply -f k8 pods. All right. Sorry about that. I should use namespace. Namespace is equal to Python -APAC 2019. Get namespaces. Okay, mali. Pycon. All right, so now our pods has been created. We can actually check. Namespace is equal to Pycon APAC 2019. It says here we have a running Pycon, so that's good. Now we check if we have a running services, so we can access the port 5000. So service. All right, so we have the external. We still have to run the service. kubectl apply. Step. Namespace. APAC 2019. So that we can get publicly accessible for our Flask. All right, so we just need to wait for at least a minute so that our external IP will be provisioned. So what we did just a while ago is just we manually apply all those YAML files, but 5,000. There you go. So now we have a running application, and it's running on Kubernetes, and Redis is also running on Kubernetes. But what if, because we're just replicating this for a one replica, when we say one replica, it's just one one node, one instance of or one replica. As you can see here, this is our under the app containers. We can actually change the number of replicas and then reapply the YAML files. And then what it does in the background is it will replicate 10 instances or replicas of our application in pods. So let's do that. Oh, sorry. There's also a one-liner if you want to automate a one-liner code of this. There's also one command that does that. But I just want to make sure that at least we can set this on YAML file. So what we do is we just need to apply the pods. Right, reapply it, and to check is we just need to get pods, then namespace. There. As you can see, it's just a matter of a few seconds, and we have a running pods. How about if I need 1,000 of those because I have 1,000 workers? Then it will spin up a number of pods. And what I like with the Google Cloud is that if you have a 3-node cluster, it will be able to compute how many number of replicas can it create on that cluster. So let's check. Now that we're using a load balancer, that load balance all these pods. See the host name change. As you can see that, because there's a load balancer that balances. You can actually try it out on your machines, on your laptop. This changes because there's a load balancer in front of that. And as you've remembered, when we apply the services YAML file, it gives us the IP, right? Now the question is, what if I just want a static IP? You know, when I recreate my load balancer, it's always the same IP. Can we do that? I don't know, with AWS probably they do, but on GCP they have that facility. They call that as a reserve IP pool. So you can reserve that. And once you reserve those IPs, it will just round robin of those IPs. But right now, we're just, the IP that's being provisioned every time that we request for our services, it's dynamic. We have no control over it. But if you want that, if you want a static IP, then we can also do that. Any questions, guys?
What's a pod?
Okay.
What's a pod versus a container?
All right. So pod is a unit of deployments. It can, the unit is, it can actually be a replica. So that's why I keep on saying replica, because it's a pods. And if I put the number of replicas, it will basically create the number of pods. And the one that we created a while ago is a replication controller. This ensures availability and scalability of your application. And what I like with Kubernetes is that when it detects that the pods is already overused, maybe the memory or it something, I mean, there's an error already, it will spin down that pod and it will spawn another healthy pods. So Kubernetes is so intelligent to know if this issue is arising. So that's why a lot of people loves Kubernetes, because it has a healing power that auto heals pods if it's being overused or there are hardware issues. And then labels is just how you name your replica sets, your stateful sets, or your services. And the nodes is actually your VM on your cluster. So that's what nodes all about when in Kubernetes. And clusters. Any questions, guys?
Have you tried serverless architecture in Docker?
Actually, using Lambda, right?
Yeah.
And not yet, but I'm actually I'm still.
Is it possible?
I think yes. I think this is actually related with each other, because Kubernetes actually runs on AWS, so you can actually use Lambda to automate things, and yeah.
I think it's a different architecture because you're just running per function. This one you're running entire Django app in a container.
Yeah, is it something
Per serverless is functions lang, like you're just running your code, diba?
Mm.
Based on events.
Is it something efficient already? Because knowing serverless, efficient na siya. And then using Dockers, is it good using serverless and then Docker being more efficient, twice efficient already, or ano?
Yeah, I think that is something that needs to be measured. Sorry, yes.
I just want to contribute to the conversation. Actually, if you attended the serverless framework presentation earlier, one of the benefits of the serverless framework is that you can use it to deploy to AWS Lambda or Kubeless. Kubeless is the native Kubernetes like engine for running Lambda functions. So if you want your Lambda one-off script to run Kubernetes, you can deploy to Kubeless. If you want in Lambda, in AWS Lambda, you can deploy to AWS or Azure or GCP. So for not AWS Lambda per se, but the serverless function, you can run it in Kubernetes via Kubeless.
If you're using cloud, you just run it in Lambda na.
Actually, yes.
But I think the difference to serverless is the serverless you only get charged when we request.
Yes.
This one in Kubernetes or Docker, if it's running, as long as the Kubernetes is running or the VM is running, you're getting charged every day. Where you serverless, you're only charged per request. There's no request, no charges.
Yes, but one possible use case is like development environments. So I may not want to deploy tons of my Lambda applications to AWS Lambda. So for short-lived environments, you could just run it in Kubeless in your dev clusters. But in production, you go ahead with Lambda because that's more reliable and it's actually cheap.
So you mean like in kubeless, spawning different functions?
Like for testing, development. Or if you want to go like totally agnostic, you can. If you have a very large cluster.
But to the fact that they're using kubeless, that means they're still using Kubernetes underlying in that system. Yes, sir.
Can I also contribute here? I think this question is about kasi the function, yung use case ng mga lambdas is really like, yung sabi niya nga by function. So normally they run in memory, so really quick, like small tasks. So ang functions ng containers is really, it's like a VM. So when you run something on a container, it's almost like indefinite running. So ang lambdas is really per millisecond time. So ganun yung use case niya. So hindi siya talaga yung parang container. And also yung spinning up ng container is really slower than a lambda. So kung i-compare mo sila, it's like tenths. Like 100 ang container, 10 lang yung lambda or even less. So ganun yung use case niya. Hindi siya yung kasing bilis ng lambdas. Even the fastest containers are slow against the slowest lambdas. Ganun siya. So, so ganun yung use case. They are complementing. Kasi kunyari yung application mo is really more on quick functions. Ganun. That's a use case for AWS Lambda. Pero yung mga, let's say, yung na microservice mo siya na formerly monolithic applications na talagang laging on, and you don't care kung yung charging mo is, kasi di ba AWS, sabi nga nung sa ano natin, sa AWS Lambda is, kaya nga siya nagla-lambda, kaya ka nag-iisip ng use case ng lambda, gusto mo kasi makatipid ng charging. So, anyway, so yung sa containers is sometimes, kahit nasa AWS na sila, may makikita ka pa rin applications na lagi naka-on. So, those are companies na talagang kaya nilang mag-shell out ng sometimes idle times. So, use case siya. Itong mga inaaral natin mga technologies naman, lahat sila, they serve something. That's why they're out there. Like AWS, kaya siya nagano ng AWS Lambda, it sees a monetizing. Kaya siya nag-serverless.
So, thank you guys. Thank you for contributing to our conversation. Actually, there's another, if you would like me to take on, there's another use case that I have. So before, we've been using load testing using Elastic Beanstalk on AWS. So you're using, if we are gonna pummel an application with 5,000 concurrent users per second, I don't know if you can imagine 5,000 concurrent users per second. That's a lot. And by having that, we need 50 virtual machines spin up to be able to support 5,000 concurrent users. And because of that, we're paying a lot of money on GCP because I think because it's a VM, it's not a container. And what I did is I talked with my boss and, hey boss, maybe we can try to implement this distributed load testing on GCP. And no, I mean, not as a VM, but as a containers. So I hope and have this. I was able to set up something like this. that will replace our current load testing. It's now on GCP. So basically, what you can do is, if you are part of the collaborator of that repo, and then if you update your locust file, locust file is actually locust actually is a load testing framework based on Python, and if you have some updates or if you have some complex use case for your load test, you can actually use locust. And then what we do is on AWS, if you're going to use the load test, you have to make sure that you have AWS CLI working on your machine with all those AWS script, with credentials, with access credentials. And you have to make sure that you have a running EB, Elastic Beanstalk, in there. But with this, you don't need to install anything. You just need to be part of the repository on GitHub. And then when you push something, it basically build the image and test if your locust is running or not. And then if your locust is running and you're ready to provision, let's say 200 nodes or 200 slaves, on locust, we call the slaves as, if you want to provision multiple replica of your locust, it says it's called as slaves. And then once you're okay with your Circle CI, you deploy it directly from the Circle CI and then deploy your slaves on Kubernetes under GCP. And it also automatically updates your images on Google Container Registry. Look at that. So let me try this out. Cube locust. So this is actually the automated version of what we did a while ago. We manually Docker build it, and then we manually push our container registry to Google Container, and then we deploy, we apply the YAML files, and all of those. But this, I automated it on our Circle CI. Let me change something. So this is how it looks like, the Python script under your locust file. So you can specify the path of the login and then put the username and password. So this particular use case is that it just go to the landing page, and then it searches for the href, and then fetch all those URLs, and then navigate to those URLs that it found on the landing page, on your home page. So let me update this file so it will trigger our circle. All right. Now I'm gonna create a branch. Dates. Then I will create a pull request. Then what it does is it will create a trigger in Circle CI to build the image, and then that image will be used, and then Docker run it on the Circle CI to check if it runs. So I think this will take 3 to 4 minutes for just the Docker build. And then later on, when we merge the PR, it will actually deploy, it will actually push the container registry on, it will push the image to Google Container, and then it will deploy the pods on Kubernetes. So this is set to 200 slaves. And let's see how it works on the Circle CI.
So does it have a way to check the resources first before it deploys standalone pods?
To check, I think it can be done. So since Kubernetes has a lot of monitoring tools, like so maybe we can pull data from that, and then before you spin up or deploy. Yeah. So now it's checked. It says here we're good to go. Now it's waiting for us to merge this. Okay, all checks passed. Now I'm gonna merge this pull request so that it will provision, it will set up the pods on Kubernetes. Okay, let's check this. So as you can see, it will try to rebuild it again, just to make sure that it's good. And then later on, I think there's another instance, but at that, in the next one, it will be deploying. It will start to deploy. It will try to apply those YAML files. Actually, this was supposed to be my another topic, load testing framework on low cost. And now that we are on GCP, we actually save around $30,000 to $50,000 a year because of this. And Dockerizing it and putting it on Kubernetes helps a lot. So now our build is checked. Now we check if it's running the deploy.
You're saying the pricing of GCP is pretty
Yeah.
reasonable.
And so 5,000 concurrent users on VM on AWS. That's like 50 VMs, M3 extra large. So 50 of that. On GCP, it's only 3 node cluster.
On the site.
3 versus 50.
3
Does it runs all the 5,000 at the same time on all clusters?
Yes.
On all nodes?
And it's being load balanced. Okay, I think we're done. And we check. Now it's trying to generate a cluster because it's already green. Cluster sa Kubernetes.
Brand new cluster.
It's a brand new cluster. So I can actually accommodate 10 load testers in one day without overlapping each other. Yes, sir.
So, since may EKS na si AWS, yung ginagawa niya ngayon currently with GCP, GKE cluster,
Well, yeah.
pwede ko rin gawin kay EKS?
Yes.
Pwede.
Pwede.
With the same like 3 nodes.
Yes. You can specify the number of nodes or which container or which plan. Right now I'm using one standard 8 and
EKS charges you for the master node, $140 a month.
Sa GKE ba?
Free master.
yes.
Sa EKS you pay for the 140 plus the yung node mo na ano is saan nag-run. Walang nag-run ng nodes, you're still paying for the EKS na naka.
Yun nga eh, it's the same setup with our Elastic Beanstalk. In Elastic Beanstalk, you're not allowed to spin down your servers. There should be running VM in there. So since it's M3 extra large, we're paying like $1,000 a month without even using it. And this one, you just pay for what you use, basically, because by the end of the load test, we delete the cluster entirely.
It's the original idea of the clouds. You only pay for what you use.
Yeah.
Kaya lang yung naging business model ng
Usually it's shadow.
Oo, kasi it's the original idea of the cloud. You only pay for what you use.
Yeah. So guys, actually, yun lang ang topic natin. I mean, I'm not yet expert on this, but it helped our company. I mean, we saved thousands of dollars by just knowing a little of Kubernetes and Docker. There. I think we're almost done. So it's now waiting for the external IP. As you can see, it applies all the YAML files now. It's trying to configure because it's 200 slaves. So it's actually creating 200 pods in there. Now I'm waiting for the external IP.
If some pods fail to get created,
It will spawn up with a new one.
I mean, will the locust test wait for all?
Oh yeah, I will show that in just a minute. Yeah. Actually, ang kagandahan kay Locust.io is it's so intelligent to load balance the number of pods, the number of slaves, and you can actually see that in the monitoring tools. All right, so I have the external IP. I can now access my load testing panel. As you can see, the slaves is increasing as the container is being generated. So with this, I can actually, the maximum number of concurrent users per second, I can around 3,900. So let's say, actually 200 lang, bagsak na yun. Hatch rate, this is actually the number of seconds. Let's say if you want to ramp up the maximum number of users for 30 minutes, then that's the hatch rate. Because ayaw mo naman na 200 kagad, di ba? Siyempre, dapat pa, just...
What's the initial start?
It depends. Usually, in my load test, I usually crank it up for 30 minutes before it reaches the maximum. So, 0.0, 0.5 para mabilis. And this is actually the site that I'm pummeling. So these are the pages that it searches and tries to navigate. And then I have here the charts showing you the total number of requests per second.
So concurrent yan, sir.
Concurrent, yes.
So 100